Okay, hello everyone. We are going to start chapter 3 now. Now this is where statistics starts getting into the things that you've heard of and the actual data part of statistics. And so the first thing we're going to look at is section 3.1, and it's measures of center. And so we call a lot of these measures of center descriptive measures. It means that it's going to give you the center or most typical value of a data set. Okay, some lingo you may hear me use throughout this video will be measures of central tendency or measures of center. They all mean the same thing. And sometimes you'll even hear me say the word average. Okay, we all know about an average when it comes to our grades and things like that. So, the mean. What is the mean? The mean of a data set is the sum of the observations divided by the total number of observations. So this is also called the arithmetic average. This is what you do when you make a 60 on one test and an 80 on another, and you find your average. You add them together and divide by 2 to get your average. This is the arithmetic mean. Take the number of observations, add them together, and divide by the total number of observations that there are in the set. Okay, that is what I mean when I say mean. Okay. All right. So, example: the following data set is comprised of a set of quiz grades. Find the mean quiz grades. So hopefully pretty soon I'll be able to put my calculator up on the screen and you'll be able to see that. Maybe next week, hopefully. But for right now, just take your scores here. Take your scores. And what I want you to do is take these and I want you to add them. Just add them in your calculator. So I'm going to do this along with you. Take your trusty calculator, 92 plus 85 plus 91 plus 90 plus 83 plus 85 plus 87 plus 90 plus 92 plus 84 plus 90. And add all those up, and hopefully you get 969. Hopefully I jumped in there and added that correctly. 969 when I add these up, and divide by the total number that there are. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's 11 total numbers there. And so this would be our average quiz grade, or our mean quiz grade. So divide by 11. And so our mean quiz grade, if we round to one decimal place, is 88.1. Okay, so that is what I mean when I say find the mean of these quiz grades. All right, so, and that's pretty straightforward. This is something you've done before. Okay, you may not actually put terminology to it, but this is something that you should be pretty familiar with. All right, so what is the interpretation of this? Well, the interpretation would be that out of 11 tests, we averaged around 88.1 on them, meaning that some were higher, some went lower, but we consistently averaged around this certain score. Okay, we consistently averaged around that certain score. All right, so let's look at mean. Now, to find the mean of a data set, now this is very important, and this is what students tend to forget, okay, when they're working these exercises. To find the mean of a data set, arrange the data in increasing order, okay? Now, once you do that, if you have an odd number of data, then the median is in the exact middle. It's the middle number. But if you have an even number of data sets, then the mean is the two middle observations, is the mean of the two middle observations. Okay, so for instance, let's take our numbers here. And the first thing you're going to do, as I said, first thing, we're going to order them. Okay, so the smallest number I see is 83. Then I see an 84. Notice how I'm marking them off as I go through these. That is just a way to make sure that I do not overlook one. And I probably still will at some point on this video, so bear with me. Then I see 390s. So that's 1, 2, 3. I see a 91, and I see two 92s. Alright, so now, how many numbers do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that means it is the middle number. So if I have 11, that means I should have 5 to one side, 5 to the other. Okay, so 90 would be my median there. 5 to one side, 5 to the other. That's an odd number. Odd number of values. We had 11. Well, what if I took this, what if I gave you this? 1, 2, 3, 4, 5, 6. Well, this is an even number of values. Okay? So what we do is we take the middle two, and notice it says take the mean of the middle two. So 3 plus 4 divided by 2. So that's 7 divided by 2. Trusty calculator tells me that this is 3.5. Okay, so that would be my median of an even numbered set. Okay, so be careful. Don't get those two confused. Odd numbered set, it's the middle number. Even numbered set, we take the average of the middle two. Okay, any questions? Make sure if you have them, ask your instructor. It's what he or she is there for, and they'll be more than happy to answer you. Okay, so now the mode. The mode is the value that occurs the most. So now it's pretty easy to locate the mode. If no value occurs more than once, then there's no mode. Otherwise, it's the one with the greatest frequency. So, for example, with this particular problem here, we have, let's see, 93 occurs once, twice. Okay, it occurs twice. 87 only occurs once. 90, I see 90 occurring 1, 2, 3, 4 times. 82 I only see once, and the rest of these I only see one time. So my mode here would be 90 because it occurs the most. The mode would be 90. Alright, so like I said, this stuff's pretty straightforward. It's just a matter of you learning the proper steps. Okay, so make sure you're putting the time and effort into the homework to learn those. Alright, so skewed versus symmetric. Okay, you'll have some different kinds of graphs, some skewed, some symmetric. And when we say skewed, we either have right skewed, which if you have a right skewed graph, it looks like this. If you notice, the mean of the data is to the right of the median. That's going to make it right skewed. Mean to the right means right skewed. Now, if the mean is equal to the median, this is a symmetric graph. This is your normally distributed bell curve, basically. Y'all don't want me to grade you on a bell curve because the scores are normally distributed, which means you would have a certain number of people make A's, certain number make B's, no matter what your score was. Okay, so this is when the mean and the median are equal, symmetric. All right, so left skewed. Left skewed is when the mean is to the left of the median in our data set. Okay, when the mean occurs to the left of the median. So kind of get this down, kind of get what it looks like. As we begin to get later in this book, we're going to talk a little more about this when we get to chapter 6 and normal distribution. We'll talk more about that middle graph, that symmetric graph. Okay? So, when do I use each measure? When do I use each measure? It's good to use mean when you're trying to, take into a numerical value. But you don't want to have extreme values. For instance, you don't want to use the mean if I'm trying to determine if a student's doing well in this class. And you have 5 test grades. And you have, let's say you have a 20, a 20, a 15, a 10, and a 100. Now, hopefully your grades aren't going to look like this, but I wouldn't want to use the mean at this point because I have an extreme value here that is, when you add all these up and divide by the total number, that extreme value is going to skew the data set. Okay? It's going to skew the data set, which means that it won't be a true average. Because if you notice, look at where all the data is grouped. If you take away that 100, all that data is grouped right in that 10 to 20 range. So really, this person's not doing well, but the 100 would skew the mean if we used it. Now, the median is best used when you have extreme values. You could take the median of this data, and it would give you a median of 20. So that would give you a better idea of how this person is doing in this class if they had these grades. Mode is best used for qualitative data like male, female, and how many of them there are. How many helps you tell how many, if you were Republicans versus Democrats, if you were counting votes and you were trying to look at ballots and things like this. Mode would be the best occurring or best measure to use in that case. Now, a resistant measure is not sensitive to the influence of extreme values. The median is a resistant measure. It doesn't matter what the extreme values are. The median is going to be the middle number of the data set. It's not going to even take into account those extreme values because they are going to be at the ends of the data sets, either really low or really high. The median is going to take into consideration the middle number. Now, mean is not resistant because, as I showed you earlier, the mean does react to extreme values. Extreme values can make our mean go up or down. Okay, so keep that in mind. Sample mean. Here's how we're going to label the sample mean in statistics. Okay, you're not just going to add numbers up and divide them. We have some symbolization here. Now, you see the epsilon e. Okay, that's called the summation notation. So basically what this says is x, how we would read this is x bar, is how we would say that. X bar, that's the mean. X bar equals the sum of x over the sample size. So basically the sum of the values over the total number of values. So for example, letter A, use mathematical notation to represent the exam scores. So this would be, I'm going to label this x1, x2, x3, x4, x5. That's mathematical notation to represent each individual score. Now, how would I do letter B and C can kind of be done together. I'm going to find x bar, that is our mean, okay? And we would say it's the sum from where I is from 1 to 5 of x sub I all over n. Okay, now what does that mean? So this tells me it's the sum of all the x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, so the sum of all this divided by the sample size. So this is just really a fancy way of saying 61 plus 97 plus 78 plus 86 plus 73, all divided by 5. And you can punch that out and get your answer for me. I'm not worried about the answer. We're talking about the notation here. So don't be surprised if you're asked to write it in that notation, or if you see it in that notation. But that's what it means. It's just wanting you to label it and add them up and divide them by how many there are. That's what the sample mean is, okay? So please try not to overthink it just because we have fancy notation here, okay? It's just the same thing that you've always done in the past. And I hope section 3.1 has been understandable for you. And again, if you have any questions, please ask your instructor. Have a great day.